In this video, we're given a radius and a rotation angle, and we want to find the coordinates of the terminal point. So we have a radius of 17, and we need to find, and we also have the angle of 116 degrees. So we need to find the coordinates of the terminal point. So to do that, we first need to draw our rotational angle. So 116 is going to be more than 90 degrees, so we know it's not in quadrant 1. I know that 116 degrees is more than 90 and it's less than 180, so I know it's going to be in quadrant 2. So it can't be in quadrant 3 or in quadrant 4. So here is my 116 degree angle that I'm going to put here. So all of this is 116 degrees. And I know that this line, this radius, has a length of 17. And so now what I need to do, so I'm actually going to make this a little bit bigger. So I know that this length is 17. Now what we need to do is find the lengths of this leg in red and this leg in blue. So I know that this line that's in blue here is going to be x. And the reason I know it's x is because this is the x-axis. And this red line I know is going to be y because my y goes up and down just like the y-axis. So what we don't know is this angle here, which we're going to call beta. But I do know that in quadrant 2, we have this equation here, where theta is equal to 180 minus beta. So I'm going to set up my equation just like this. And now I have my theta, which is 116, and that's equal to 180 minus our beta. So now what we need to do is we need to solve for b. So I'm going to solve for b by adding b on both sides, just so we can get it to the left, and it's a little bit easier maybe. So b plus 116 equals 180 because these guys cancel. And now I have to subtract 116 on both sides in order to get b by itself. So our angle for beta is equal to 64 degrees. So this is not my answer, but it's going to get me pretty close to it. So now what I need to do is I need to find the lengths of x and y. So to do that, we can use sine and cosine. So I'm going to use the sine of our angle, which is now 64. So we do know that now. And so sine is opposite over hypotenuse. So opposite of my angle is the y, and the hypotenuse is always across from the 90-degree angle, so that's 17. And now we're solving for y by getting rid of the fraction. So by multiplying by 17 on each side. And now I'm left with my y value, and 17 times the sine of 64. So now when we put this in the calculator, we're going to get a value of 15.3. So remember that you have to be in degrees on your calculator. If you're not in degrees, then you're going to have the wrong answer. So I know that this is my value for y. Now I want to get my value for x. So I'm going to do something very similar, but now I'm going to use cosine of 64. And cosine is equal to the adjacent over the hypotenuse. So if we look back at our triangle, the side that's closest to the angle, so this one right here, this is our adjacent side. So that's going to be x. And the hypotenuse, again, is across from the 90-degree angle, and that's 17. So again, I go to cancel out the 17 so I can get rid of my fraction. Now I'm left with x on the right, and now I have 17 times the cosine of 64. Again, make sure you're in degrees. This way you can get 7.5 as your answer for x. So now what we have to do, this is our last step, is to put this in an ordered pair. So we know that an ordered pair has x first and then we have y first. So I put a little note here that cosine is x and that sine is y. So I'm going to put cosine and then sine here. So my value for the cosine, when I used cosine, we had 7.5. So I know that my cosine has to be 7.5. But let's look at where this is. So that's my line of x. But look at my x value. We went to the left. When we go to the left, or if we're in quadrant 2, our x value is going to be negative. So I have to put this negative here. Even though it wasn't in this value here, we know in our diagram that we're going to the left, so we have to put negative there. And now same thing for y and for sine. So when we used sine, we got a value of 15.3. So I'm going to put 15.3 right here. And again, I need to go up here and see, okay, well, we went up. So when we go up, or when we're in quadrant 2, our value, or our sign for sine is positive. So I'm going to keep this as positive 15.3. Again, we don't have to put this positive, but I'm just going to put it there just to make that clear. So again, once you put in your points into your ordered pair, you want to see where it's going and if that's going to be positive or negative. So this is your, that's the coordinates of your terminal point. So this point right here.